start with a sip of water. I didn't actually go out yesterday, so I'm not that dehydrated, but kind of wish I did. I'm kind of happy I didn't. Who went out yesterday? Oh, I guess the people who went out are probably still asleep. All right, so today I'm going to talk about sub-second acceptance tests. And that might actually sub-second full-stack acceptance tests is really the title of my talk, but that would have just been too long to write. And that sounds like a bit of an oxymoron, I think, because that's something that hasn't been seen a lot. A bit about myself. So, I've been doing agile development, I guess, since I got infected by the Kent Beck book. Extreme programming. Quite sad that extreme programming kind of lost out to Scrum. I've been involved in the open source community for a couple of decades. Started out actually I think I was one of the first contributors to Selenium when Jason Huggins showed me his little robot thing clicking around, and I wrote a little bit of Ruby code that hopefully has been deleted by now in the code base. It was a very short engagement with Selenium. But then I went on to create Cucumber, which I guess didn't really plan for that to become that popular. Who here uses Cucumber? Okay, quite a lot. So today's talk isn't really going to be about Cucumber. I will show you a little bit, but it's really about programmer happiness. And I love to program. I consider myself a software developer and not a tester, although I do test a lot. And because I've been a programmer for many years, I remember when programming was fast. I could just, web development was fast. I could just hit refresh in the browser and everything would refresh in the browser. But now, as computers are becoming more powerful, for some reason, the development experience is getting slower and slower and slower because we're just piling up with so many different things in our stacks, in our architectures, our build tools, and everything, and it gets really hard to get into the zone. So being in the zone is a bit difficult to explain, but it's the kind of feeling when you're just so engrossed in the experience that you sort of lose track of time and space, and somebody's talking to you and you can't hear them. Has anyone experienced that feeling? Right. It's amazing. It's amazing when you get there. And I used to be in the zone quite a lot, and I've realized that as the years have gone on, I find it more and more difficult to get into the zone. I guess one of those things, I don't think it has to do with age. I hope not. But like I said, I think there's a lot of things in our environment that makes it harder and harder for us to get into the zone of programming. And I think that's something that we need to pay attention to, because in order to be productive and in order to be happy at work, we have to be able to get into that zone. And so so this is something that I've been interested in over the past couple of years. How can we sort of reclaim that space that we used to be in? So I've started to explore a bit about, okay, what are the underlying principles of getting into the zone? And I came across this book called The Everything Psychology book by a lady called Kendra Cherry. And in this book, she describes 3 components of flow, the state of mental flow. Now, the first one is that you can have immediate feedback. So whatever you're doing, you will know straight away whether that thing you're doing is working or not. And this, sports people have this, people who exercise, if you're a downhill skier, you have immediate feedback so you don't crash into a tree. But it's also important when you're a programmer to have immediate feedback. And this is becoming increasingly difficult, I find. Another important component of flow is the feeling that you can succeed, being confident. If you're not confident, you feel like you're sort of in the dark, you don't really know where you're going, and you start doubting what you're doing, and then it becomes really hard to be productive if you don't feel that you're in control. And by the way, this book here is about general psychology, right? So this applies to anything you do. Now the third component of flow that she writes about is the feeling of being so engrossed in the experience that everything else just becomes negligible. So maybe you've got some problems in your life. I guess we all do, things that we worry about. But if you're able to forget those things when you're working, that means you're kind of in the zone. You've kind of blocked up those distractions, and you can just focus on the work. And there's another book about flow as well. I'll go through them quickly, by a man called Mihai Csikszentmihalyi or something. It's very hard to pronounce. Has anyone heard of this book? Very interesting read. And he describes this intense concentration when you're in the flow. And you have this merging of action and awareness. And you have loss of reflective self-consciousness. You kind of forget that you're a person. You're just like the thing that you're working with, and yourself is almost like the same thing. And again, the sense of personal control or agency, distortion of temporal experience. You realize, you look at your watch and it's 6 o'clock, and last time you looked at the clock, it was like 2 o'clock, and you didn't really see the time flying because you were just in the zone. And the last one is something called autotelic experience, which means that you feel that the experience is intrinsically rewarding. You just, the endorphins are just rushing to your brain. This is so awesome. I just love this. But making the conditions for these kind of things to happen can be quite hard, and there's quite a lot of things in the way. And time feedback is, or the latency of feedback is quite important. Jakob Nielsen wrote a book about, I think it was in the mid-90s, about user experience and human-computer interaction. And in this book, he talks about 3 important time limits that you should be aware of when you design user interfaces. And this, this is before the web took off. But this is based on some research that's been done in the 60s, and the findings haven't really changed in the past 40, 50 years. So the 3 time limits that Jakob Nielsen talks about is, well, the first one is 100 milliseconds. So if you imagine a person sitting in front of a computer, if they can get feedback within 100 milliseconds, they feel like the system is responding instantaneously. So you don't need any particular kind of visual feedback if you can respond to the user that quickly. And think about what the psychologist said, right? In order to get into the zone of flow, you need to have that sort of immediate feedback. So this is research done for user experience design, but it does apply to us as programmers because, well, there's a user experience involved when you're interacting with the programming tools. So the next time limit in Jakob Nielsen's book is 1 second. So if you're interacting with a system that takes about 1 second to respond, you can still, your thought can still stay uninterrupted. You can remain focused at the task at hand. You're starting to notice the lag. If you've been on a video conference, you all know that if there's more than half a second of lag, you notice the lag, but you can still kind of stay focused. It's a bit annoying. So you don't really need to get direct feedback like spinners and progress bars within 1 second. But the user is kind of losing the experience of operating directly on the data. Now, the third time limit that Jakob Nielsen talks about, and this is a critical one, is 10 seconds. If it takes 10 seconds from you do something until you get the feedback, you can no longer keep or stay focused on the task at hand. Your mind starts wandering. Your brain is trying to fill that gap with something. And this is when you start maybe quick Alt-Tab to check Twitter or Facebook, or maybe you go and turn around and talk to somebody, or you start doing something else. And this is when, if you're in some sort of sense of flow, if you have to wait for more than 10 seconds, you're out of the flow. You're out of the zone. Now, why am I talking about this? Well, like I said, increasingly, the programming environment that I'm working in has become slower and slower. So I can't get into the zone. Here's a cartoon by XKCD. You know, it's just mocking how long it takes to compile the code, and then people start doing something else. And this doesn't just apply to compilation, right? This applies to tests as well. So if our tests are slow, you know, you take that sword out and you start playing around with your colleagues. So what have we done in the community to try and deal with the fact that we have slow feedback? Well, in the testing community and software development community, you know, people have come up with the test pyramid. It was originally coined by Mike Cohn and then popularized by Martin Fowler, and then, you know, the community just took that guideline and ran with it. Has everyone heard of the test pyramid? I guess most of you probably have. Test pyramid basically says it's a guideline about the proportions of different kinds of tests that you should have in your test suite. So it says you should have loads of unit tests and not quite as many service tests, whatever that means, and then very few UI tests on top. And the reason for this is that testing through the UI is slow. You know, you get slow feedback, and they tend to be brittle and expensive to write and time-consuming to run and so on. And I took this for granted for a long time. And I was telling my teams that, yeah, we shouldn't have that many UI tests, you know, try and push everything down and do unit testing. But, you know, there's still a lot of logic in the UI that you want to test. So that's a bit problematic. How can we have confidence that the system is working if we're just going to have very few of those tests? So people inevitably end up with lots of really, really slow tests. And you know, they can take minutes or hours to run, so programmers can't get that automatic, you know, that really instantaneous feedback when they're programming, which means that they can't get the confidence, and it's harder to get into this zone of flow and be productive. So people come up with all sorts of different ways to deal with this, to work around this thing, right? We've seen some talks here at the conference about scaling them out to, you know, to run in parallel in the cloud. That's one way you can do it. You can buy beefier machines to the developers so they can run them a bit faster locally and so on. But I think this is solving the wrong kind of problem. And I think this test pyramid is a bit of a flawed concept. Well, I think the idea is kind of, the idea behind it is sound, but there are some problematic assumptions in there. So let's explore those. I got a version of this pyramid which I call the love-hate relationship pyramid, which looks like this. So if we forget for a moment, you know, UI tests or unit tests or service tests or integration tests or whatever, really what we care about, right, is that we want to have very few of those tests that suck and lots of those tests that we love, right? That's really what we want to have. And, you know, somewhere in between with the meh tests. So what is it? What are the characteristics of tests that we care about that makes us love them or hate them? Well, one of them is speed, right? So we want to have lots of tests that can run in just a few milliseconds, and not very many tests that need more than 10 seconds to run, right? It's kind of a given. That's how we can get fast feedback. Another thing that we care about is determinism or brittleness, right? How often, if I run this test over and over and over again, how often is it going to fail? Well, because if it fails, you know, 1 out of 3 times or 1 out of 4 times, you know, I kind of lose confidence in my test suite. And people start not caring about whether they're passing or failing. And if you don't care about whether they're passing or failing, what's the point in the first place of having the test? Right? It doesn't really tell you anything. It doesn't tell you whether there's a problem in the software or a problem in the test. It's kind of like a useless test. But still, people have lots of really, really flaky tests, right? So we want to have few of those, and we want to have loads of those tests that are completely 100% deterministic. They always behave the same way. And the third characteristic that I think is important for tests is maintenance. Like how much time do we spend writing or maintaining those tests? Well, most of our tests, we want to be able to write them in just a few minutes, or if we need to change the software, we can update them in just a few minutes, whereas we do have some other tests that we can end up spending days just writing or changing if something changes. And there's a fourth version of this period, which I didn't draw up, but I'll tell you about it. That's what I call diagnostic precision. When a test fails, how easy is it to pinpoint exactly where the problem is? We want to have loads of the ones that can just tell you exactly where the problem is, and not very many of the ones that don't tell you anything, right? So back to this love-hate relationship pyramid, there's lots of things there's 3-4 things that we need to care about that are important to determine whether we love or hate a test. It's the speed, how fast are they, how deterministic are they, how expensive are they, and how good error messages do they give us. So the testing pyramid that has been popularized over the past decade, it just makes the assumption, right, that, well, end-to-end UI tests, they have all of the bad characteristics. And unit tests have none of them. And I think that's an oversimplification. And it makes a lot of assumptions about how you've architected the system under test and also the tests themselves. And I think that conflation is probably based on heuristics that most systems are architected in such a way that UI tests are slow and brittle and expensive and so on. But I'm here today telling you that it doesn't have to be that way. Okay? We can do better than that. So let's have a look at a typical test suite, and we're going to build it from the top to the bottom. Imagine it's a web app with maybe a React front end and maybe a Node.js backend talking to a database. So at the top here, we got a test, right? So this can be a JUnit test or a Cucumber scenario. Doesn't really matter what it is. But we got a test sitting here, and it needs to interact with something. So in this drawing here, I've called this thing a WebDriver actor, and I'll get back to why I've called them this way. But for now, let's just go with what's here. The thing that's important to look at here is, how these things are connected. Has anyone here played with Lego? Right. So I grew up spending most of my childhood playing with Lego, and Lego has 2 sort of interesting things. It has studs and pipes. So the studs are the things that go up, and the pipes, that's the holes underneath. Right? So you can imagine this is a Lego. This top Lego fits on top of the bottom one. And, well, this is a bit of a special Lego here because the studs at the top aren't similar to the tubes at the bottom, but the principle is the same. So I'll have to fit a different kind of Lego underneath here. So let's have a look at one of those. Well, here we've got a browser. So if we imagine that we've got the test, which is JUnit or Cucumber, and then we've got WebDriver, and then WebDriver sort of plugs into the browser, and the browser plugs into the DOM, and the app that we're testing, the front end, the React app, or Vue, or whatever it is, plugs into the DOM as well. And then that needs to talk to the back end somehow, to send and retrieve some data from the web server. So maybe we have a little abstraction layer here in JavaScript for interacting with the back end. And by the way, the colors here, they mean something. The green means test. The pink means infrastructure. That's not our own code, but just stuff that we have to deal with. That's part of the whole stack. And the orange is front end. And there will be some blue underneath here, which is back end. So, yeah, so this thing, HTTP API client talks to HTTP to some sort of back end that receives HTTP requests, which finally interacts with some domain logic, and there's some DAO to talk to a database, and then there's a database at the bottom, right? So there's lots and lots and lots of layers. And people are wondering why the tests are slow. Well, it's a fair question to ask, why are the tests slow? Now, it turns out that there's only 3 things that can make a program slow. You can sleep. That makes it slow. That's not something you typically do in production code, something that people end up doing in test code a lot. But sleeping is definitely one thing that will make tests slow. The other thing that makes tests slow, or not tests, but programs in general, is networking. A program is typically limited, the speed of a program is typically limited by either by I/O or by the CPU. So the third thing is the speed of the processor. So sleeping, I/O bound, or CPU bound. That's the only things that can make a program slow. And how can you make things faster? Well, you can stop sleeping. How can you make something that's I/O bound faster? Well, there's 2 ways. You can buy a faster network. That'll make it go faster. Or you can remove the I/O. That's a bit more tricky. And how can you make something CPU bound go faster? Well, you can buy a faster CPU. Okay? Now, what's the main reason this is slow here? Is it because we're sleeping, or is it because we're I/O bound, or is it because we're CPU bound? I'd say most of the time it's because we're I/O bound. Right? There's lots of networking in the stack here. If you look at the top, from your test thing here, from your test to Selenium, there's networking. A couple of layers, maybe 2 or 3, because you need to talk to the Gecko driver, which needs to talk to the browser, and then the browser needs to talk down to the server again. So what if we can remove that slow bit? Let's try that. Okay. So what I did now was I pretty much will play it again. I removed the Selenium bit and the browser bit. And I plugged in another Lego, which has the same interface at the top and the bottom, and I can run my test again. So my test is now a lot quicker. Now it just takes 1 second rather than 10 seconds because I removed the slowest bit of the system. But we can do better than that. So once we do that, we discover the next bottleneck. Well, where is it going to be slow now? Well, let's try and remove some more stuff. Okay, so I removed a bit more of the stack here, but I still have the most important functionality intact in my app. I've got the React app, which is all the logic in the front end, and I've got the domain logic, which is on the server. But now I've just sort of jammed the front end straight in with the back end, and this is, in this case, this is a Node.js program on the back end, so I can actually run the front end and the back end in the same process. So I removed I/O, I removed HTTP, and it's really, really fast. This test now runs in 100 milliseconds. We can also get rid of the database. We can plug in a different sort of DAO, maybe some sort of stub or a memory DAO at the bottom. And now we're down to 10 milliseconds. And then we can plug out some more stuff. We've got all these different configurations that we can, we can assemble our system in different ways, depending on what we're looking for, whether we're looking for confidence or whether we're looking for speed. So you'll notice here that the tests at the top, they're the same. That Lego that sits on top of each of those piles is the same test. But it's running in a different assembly. For each column, you've got a different kind of assembly of different components. We take the one on the left has all of the production components, and the further you go to the right, we've swapped out some of those components with fakes or stubs or mocks. And as we go, as the height of those columns becomes shorter, the tests become faster, and they become more deterministic, and they give you better error messages when they fail because there's no networking, so you get a stack trace. But at the same time, we get less and less confidence, or we get different kinds of confidence. On the right side, we still have confidence about the functionality of the application because we still have, well, let's look at this one here, the third one. We still have all of the essential logic pieces of our application. We got the back-end logic and we got the front-end logic. We just removed a lot of the infrastructure in between. And on the left, we get a lot of confidence there, but that's a different kind of confidence. Well, we do get confidence about the functionality of the application, but we also get confidence about whether this works in all of these different kinds of browsers, for example. And I think this is a problem with a lot of tests, is that we're trying to get too many different kinds of confidence from the same tests, right? You want to check that it's functionally working okay. Like, did we implement the business logic correctly, and did we implement the UI correctly? That's one thing. That's not the same as getting confidence that it runs on all of the different browsers. It's a different kind of confidence. So you can get this kind of confidence from different kinds of tests. Integration is another thing. Did we wire everything up correctly? Did we set all of the ports and paths and keys and whatnot? That's a third kind of confidence, right? So I think we need to stop trying to get all of these kinds of confidence from the same tests, the ones on the left. The ones on the left will give you all of these things, but it comes at a very, very high cost. So I'm going to give you a demo. So let's look at what's inside of this test at the top here. If we crack open one of them, it might look like this. So in this case, I've got a little game. This is a game that I like to play with my daughter, who's 6, who's learning to write. We sometimes play it if we're traveling. I think of a word. She tries to guess the word. It's a 5-letter word with unique characters. I say, okay, I've got a word. And she says, I don't know, hello. Now, there's 2 L's in hello, but I'm not gonna mind about that. So I'm telling her, okay, hello. So you got 1 letter correct. And then she guesses again. And I tell her how many letters are correct, and she's trying to figure out what word I'm thinking about. So this is something you can play on paper, or just, you don't need a computer for that, obviously. But this, I'm trying to write a program that can let you play this online. So I got this scenario here that describes, this is one test for this little program. Now, what kind of test is this? This is a functional test, right? But is this a UI test? Is this a full stack UI test? Or is it a unit test? What is it? Well, it's a Cucumber scenario, so it's kind of got to be a full stack test, right? Well, no, it doesn't have to be. It depends on how I wire it up with the system under test. So if you look at it, one way that I could run it through WebDriver, through a browser, and all of the things that are below. Or I could run it through some other kind of way to interact with the UI, using something called the DOM actor, which I'll show you. Or I could just wire it straight into the domain logic, which sits on the server. Now, so the interesting thing here is that the test itself is completely decoupled from the system under test through this contract, which is called the actor interface. That's the interface here. So the test is interacting with the system through a domain-specific contract that expresses what a user can do with the system, but not how. And the way this contract looks is like, in the case of this game, it's like this. The test can send domain-specific commands to the actor, like try and guess a word. And then it can make observations about the system by using something that I call test views, which is just a way to get simple data structures out of the system that completely decouple information like whether whether I'm interacting with the system through a user interface or through an HTTP API, or maybe with direct method calls, right? The test only knows about this very high-level API, which is domain-specific. And then I've got different implementations of those actors here, depending on how I've assembled the system for this particular test run. Now, there's a couple of other things that are important here. When you write your test this way, you can't make assumptions about the user interface in the test, right? Because if you do that, if your test is written like, I click this and I enter that and I look at this, the text of this this div and so on, you wouldn't be able to reuse that same test against an HTTP API or against something running in memory. So you're kind of forcing yourself to express the test in this way, which is actually a really good thing. That's one of the things I've been trying to make things do for 10 years, to express tests as business readable, domain specific language, and not clicking around in a UI. So I'm going to give you a demo so you can see how this works in practice. And then we can look a little bit at the code. All right. So I've got the, there's a couple of, oops, you can't see, sorry. I just need to turn off mirroring, turn on mirroring. Can you see now? Right, okay. So here we got a couple of scenarios, and you've got the corresponding step definitions here. And as you can see, the step definitions, they are just basically translating the text on the left, which is Gherkin, plain text, and interacting with this actor here. So I can join a game, I can get the number of letters in a current game, and so on. So let's run this. So I'm going to try and make this a bit bigger. Is that font size all right? Do I need to make it bigger than this? In the back? Yes? Cool. All right. So I'm going to do yarn. Oops. So when I run this now, it's going to run those scenarios many times for all of these different kinds of assemblies, and I'm going to start with the fast ones, and it's going to be slower and slower. Actually, you know what? That's kind of boring. I'm going to make it a bit more. I'm going to create 100 tests here. I'm just going to copy those. That's 4, 6, 8, 10, and then I'm going to copy that 9, 10 times. Right? So now I've got 10 here, so 10, 10, 20. Okay, so I think I have about 100 tests now, so let's run it. It's getting progressively slower. Be patient. I think you get the idea. I'm going to stop this one. So let's go back and have a look. So in the first configuration, I call these things assemblies. So in the first configuration, I ran 100 acceptance tests or functional tests, right, in 83 milliseconds. So that's about a millisecond. That's less than a millisecond per test. It's pretty good. Okay, in the next one, I'm running the UI tests, but there's no networking, there's no HTTP. I've just plugged the UI straight into the domain logic, removed all networking. It takes, 5 times as long. It's still pretty good. I'm running 100 UI tests in a third of a second. Like, that's 3 milliseconds per UI test. Pretty good. Okay, in this case, I'm just running against the HTTP API. I'm running the same test. That takes a bit longer because there's networking here. So that took me about 10 milliseconds per test. Here I'm running DOM together with HTTP, taking even longer, 2 seconds. And obviously, with WebDriver, it's going to take a lot more time because there's just a lot more going on. So if I'm in this kind of scenario, well, what's the point of running WebDriver tests at all? Well, like I said previously, is to get a different kind of confidence. So I think of WebDriver as a great tool to check that the UI that you built will work in all of these different kinds of browsers. It's not a great tool to verify that all of your business logic is correct. There's way cheaper ways to do that. I can just show you a little bit how these things work. So let's have a look at the these different actors. So here is the direct actor. That is just talking straight to the domain logic. We've got a DOM actor here. Hang on. So yeah, this is just I'm just interacting with the thing, with the business logic directly from the test. Whereas in the WebDriver one, I've got exactly the same methods, but I've implemented them differently. I'm looking up DOM elements and clicking and so on. So some of you are probably thinking about page objects here. So this is a different way to abstract away the UI. So I'm not abstracting the UI away into pages because I think page objects is the wrong abstraction. Because a page object is very UI-centric. Right? I don't want to be UI-centric. I want to be business rule-centric. I want to be centric to whatever the user is trying to do, whether or not they are using a screen or not. I don't care. So my tests are written from the perspective of the goal that the user is trying to achieve, and then that's what we're abstracting away, rather than pages. So it's the same idea as page objects, but it's more like, I don't know, action objects or actor objects. Yeah, so I guess that's really what I wanted to show you, that you can write your test in such a way that you can get different, you can have a trade-off between I want really, really fast tests that give me confidence about the implementation at the cost of the confidence of that it runs in all of these different kinds of browsers. And last time I gave this talk, I didn't leave any time for questions, so this time I've left about 5-10 minutes for questions, so I'm happy to take questions.
Make sure it's on this time.
Okay. I just wanted to ask, you were talking about replacing the WebDriver with a DOM agent, and are there ways to do that outside of a React stack?
Yeah, it's not specific to React at all. So I can show you the code real quick. So the DOM actor looks like this. It's very similar to the Selenium one. It's got a bit of it's got a bit more setup here, but the implementation of these are pretty similar. And there's nothing React specific here. I'm just interacting with the DOM. So I could rewrite the entire app in Vue or something else, and I wouldn't even have to change the tests. So it's not using the React. The test isn't using the React API. It's just using the standard browser DOM API. Yeah.
Anyone else? Yes? All right. You got it, Ed. Think. Good.
Hi. So in this, what you showed, is your underlying application has to be in Cucumber based, or you can just be independent?
Does the underlying application have to be Cucumber based?
Yeah, so you have to have your implementation also in Cucumber and then test also in Cucumber to have more like a mapping of those ones, or your test can be agnostics?
No applications have dependencies on Cucumber. If you write an application that depends on Cucumber, that would be a very strange thing to do. So, yeah, you can. The answer is no.
Okay.
It's Cucumber that interacts with the application. The application doesn't interact with Cucumber.
Will you be providing the files for this somewhere?
Yeah, it's on GitHub.
Awesome.
I'll put up a slide with the URL. There's a question behind that.
Go back here. Okay. I'll head this way. You head that way.
So, do you advocate then basically for maintaining multiple suites for getting different types of confidence?
Do I advocate maintaining multiple suites for different kinds of confidence? Well, actually, no. I advocate maintaining one suite that you can run in different configurations or assemblies, as I call them, for different kinds of confidence. So I can run the same test in many different ways, depending on what sort of confidence I'm looking for. But it's still just, I've only got one implementation of the scenario here, and I've only got one implementation of the step definitions here. But what I have different, what's pluggable is, these actors that the test uses to interact with the system. So from a maintenance perspective, the only thing that you need to sort of duplicate, or that's those actors that act as the sort of the glue between the test and the system. So it isolates the things that you need to duplicate into very small pieces.
Doesn't this assume it's a single-page web app for like the faster tests?
Doesn't it assume it's a single-page web app for the faster tests? I haven't tried to. I'm not sure actually. I haven't tried to do it with a more standard request-response web app. You could. I'm pretty sure you can use the same principles there. It's just a slightly different implementation of those actors.
So in the example that you showed here, it looks like you're kind of mocking out the DOM. You're rendering the DOM in your test code. Do you imagine that
I'm not mocking out the DOM. No, it's the real DOM.
Okay. So does this live in? Do you imagine this would live in the, like, if you have a web app, it would live in the web app repo? If you have React, you're using like deep rendering and then injecting that into your test code, or what does that look like?
So when I run the UI tests, the fast UI tests that run in a few milliseconds, and it's actually running inside of Electron, which is the same platform that applications like Slack and some of the modern text editors are built upon. It's essentially a desktop environment for browser application, or lets you write desktop applications in a browser. So from a technical perspective, that's basically Chrome and Node.js had a bastard child. It's Chrome and Node in the same process. So the tests are running on a real DOM, the same as the one you find in Chrome. I'm not sure if I answered your question correctly, though. So feel free to ask again if I just completely went off on a tangent.
So what sort of criteria do you use to determine which tests require the full stack to run versus the ones that can be run really quickly with a lot of abstraction?
Yeah, that's a good question. I don't really have a good heuristic. In Cucumber, you can put tags on scenarios. So I could sprinkle some tags around some of these scenarios and just to select the ones that I want to run in the slower configuration, right? But how do I pick the ones that I care about? Don't really have a good heuristic. I don't think it matters that much. I would pick the ones that are likely to expose any platform problems, but don't have a good heuristic.
I think we have time for one more.
So your demo and your implementation of the actors displays a level of familiarity with the business logic that's pretty intimate, a white box approach. Have you ever had any success with a black box DOM reverse engineering sort of approach? I mean, do you really, can you do this from the outside, do you think?
I'm not sure I understand the question.
I mean, so let's say that all you can observe is not the business logic as it's implemented to interact with the DOM, the code that runs the React app, but just the interactions at the browser level. That is, you're going to go through it, you're going to reverse engineer from a proxy or maybe spy on an interaction with a profile interaction with the DOM, and then try to extract from that enough information to implement a DOM actor. You think that's a fool's errand, or have you ever tried to do it from a sort of a black box?
My approach to this is TDD. So I always write the test before I write the implementation. So I don't really try and approach the problem from that angle. So I haven't tried. But if I were to write a new, the application that I showed you is very basic at the moment. When I'm going to write a new piece of functionality, I'm going to start with the test, and then I'm going to run it, and then I'm going to start fixing wherever it fails first. Whether I can start in the UI, I can start with the back end. Depends on what I feel like that day, I guess, where I want to start. But yeah, this reverse engineering thing is something that I don't really do test after.
All right, that's it. I thank you, Aslak, for your insights. I think this morning we'll take a break until 10:30. We have some refreshments back on the 15th floor. But Give a round of applause to Aslak.
Thank you. Thank you very much.